Hello students, we are going to be looking at equations involving logarithms. I have three good questions that I'm going to solve with you for proper understanding. So let's start with the first question. Log k minus log of k minus 2 is equal to log 5. The first thing, collect like terms. In collecting like terms, you are going to have log k minus log, then we have k minus 2 minus log 5 is equals to 0. Since we have this, I want to remind you from one of the laws of indices that has to do precisely with subtraction. It is stated that once you have log m base x minus log n base x, then this is written as log m divided by n base x. All right, that's exactly what I'm going to be doing here now. So this is going to be log of k, all right, then my divided by, instead of minus now, k minus 2, then divided by 5, of course, is equals to 0. So I've applied the law. Now expressing it further, this is going to be log, then I have my k. This is going to be times 1 over k minus 2 times 1 over 5 is equals to 0. All right. Now moving further, this is going to be log. I have k now all over 5 into k minus 2. Okay, is equals to 0. Now recall that whenever you are working and the base of the log is not expressed, it means it is in base 10 or base of 10. So this is 10. Now recall again that from the beginning of log, you'll be taught the definition of log, where you can actually change log to indices, where if you have log y base x is equals to n, this can be written as x raised to power n is equals to y. I'm going to use that, okay? Now using that to actually work this question further, I'm going to have 10 raised to power 0 is equals to k into 5, then k minus 2. All right. Then remember from your indices, 10 raised to power 0, of course, is 1. Then this is equals to, let me write it well. All right. This is going to be 1. Then is equals to k all over 5, 5k, then minus 10. All right. Having it this way, this cross multiplying now, I'm going to have 5k minus 10 is equals to k. Collecting like terms, I'm going to have 5k minus k is equals to positive 10. All right. Now, having this, I'm going to have 4k is equals to 10. So k is equals to 10 over 4, which is the same thing as 5 over 2, which is the same thing as 2.5, which is the same thing as 2.5. We are done with this. So quickly, we are going to go to the second question. Now we have the second question on the screen. Just like we applied the law for subtraction of logs, the same thing we're going to do here. So this is going to be log 3, then I'm going to have 4x plus 1, okay, divided by 3x minus 5. You close the bracket, is equals to 2. So this is going to be log of 3, then I have 4x plus 1 all over 3x minus 5 is equals to 2. Remember that definition thing that I told you? I'm going to use it again here. So I'm going to have 3 raised to power 2 is equals to 4x plus 1 all over 3x minus 5. So this is 9 is equals to, I have 4x plus 1 all over 3x minus 5. Okay, cross multiplying, I'm going to have 9 into 3x minus 5 is equals to 4x plus 1. So this is 27x minus 45 is equals to 4x plus 1. So that I'm going to have, collecting like terms, 27x minus 4x is equals to 1 plus 45. So I have 23x is equals to 46. And x is going to be 46 all over 23, which is 2. So we're done with this. Quickly, let's go to the third question. Now, having the third question on the screen, the same thing. I'm going to collect like terms. So I have log of base 2, then x squared minus 2 minus log of log to base 2, then x minus 1 is equals to 1. Applying the law, this is log to base 2. This is going to be x squared minus 2 divided by x minus 1 is equals to 1. Of course, applying the definition, this is 2 raised to power 1 is equals to x squared minus 2 all over x minus 1. Cross multiplying, I'm going to have 2 into x minus 1 is equals to x squared minus 2. So this is 2x minus 2 is equals to x squared minus 2. Now we need to collect like terms, okay? Or since it is tilting towards a quadratic equation, we're going to make it look like the format of a quadratic equation. So I'm going to have x squared minus 2 minus 2x then plus 2 is equals to 0. Okay, I want to believe you understood what I did. I picked the whole of this, cross it over to the right hand side. So this cancels this. So I'm going to have x squared minus 2x is equals to 0. So we work this quadratic equation by factorizing x out. This x minus 2 is equals to 0. So it is either x is equals to 0 or you have your x minus 2 is equals to 0. So x is equals to 0, and at the same time we can have x is equals to 2 when we work it out individually. So this is how to work out this question. It's not hard, it's simple. So when it comes to equation involving indices, I think we've done justice to this. So keep watching. I'm going to be solving some very good questions too under this equation involving logarithms in part 2.